You imagine the universe as a tidy story. You think the first billion years were simple, predictable. You see galaxies forming like clockwork, matter behaving like it always does. You think the sky's history is written in neat lines and graphs. You imagine the early cosmos as a calm, unfolding blueprint. It isn't. It never was. Everything you thought you understood about the infant universe, its structure, its growth, its rhythm, is suddenly fragile. You picture the heavens as a stage, each star and galaxy in its assigned place. The truth, the stage is still being built. The actors are improvising, and your mental picture, the one you've held for years, is quietly collapsing. The Euclid Space Telescope just pulled back the curtain, and what it revealed does not resemble the story you thought you knew. You think the early universe was simple. You imagine a vast, empty canvas, and then matter painting itself neatly into galaxies, clusters, and filaments. You picture the cosmic web as elegant, as if some invisible hand arranged stars and gas into predictable patterns. This is wrong. From the moment the first atoms combined, the universe was not a clockwork. It was not a tidy stage. You imagine uniformity, smooth expansion, small fluctuations gently growing into the structures we see today. But the reality, as Euclid now shows, is much less forgiving. The telescope's new maps reveal regions of space that shouldn't exist. Clumps of galaxies where models predict emptiness. Filaments stretching farther and thinner than theory allows. Early galaxies appearing too massive, too bright, too fully formed. Your mental picture, a universe slowly settling into order, is already fragile. Consider how you probably visualize cosmic time. You see it as a straight line, a progression from a hot, dense beginning to the universe we inhabit now. You imagine a gentle unfolding, but that line is a lie. Euclid's observations suggest that some structures grew faster, some regions denser, others delayed. The universe was uneven from the start, not chaotic in the sense of random noise, but uneven in a way that defies simple rules. You may assume this is a minor detail, a curiosity for specialists, but it isn't. These deviations accumulate. They ripple through every calculation, every model, every intuition about the first billion years. What you thought was predictable, the formation of stars, the assembly of galaxies, is now provisional, contingent, fragile. Think of your intuition as a sandcastle. You've built it carefully using the grains of knowledge you've gathered over years, textbooks, documentaries, lectures. Euclid comes along like a wave, washing away the foundations. What you see is intact, but underneath the structure is hollow. And you didn't even notice the cracks until now. Even your mental picture of empty space is misleading. You imagine a calm void between galaxies, but early space was turbulent. Gravitational fields twisted, dark matter streams intersected, regions of collapse and expansion intertwined. There was no smoothness, no serenity. The order you relied on exists only in hindsight, reconstructed from fragments of light and shadow. So the next time you picture the infant universe, try not to imagine calm progression. Try not to imagine galaxies assembling like clockwork. That story, the one your intuition whispers to you, is wrong. What Euclid shows is something more complex, more uneven, and ultimately stranger than your imagination can contain. And this is only the beginning. You imagine the early universe as a calm, orderly nursery, where galaxies grew like carefully tended seedlings. You picture matter coalescing smoothly, stars igniting one after another, clusters forming along neat filaments. That image is comforting, but it is wrong. Euclid's observations expose a cosmos in disarray. Galaxies appear in places they shouldn't. Some are already massive, already luminous, already fully assembled, at moments when our models say they shouldn't even exist. Regions that theory predicts as sparse are dense. Regions that should be crowded are almost empty. The pattern is inconsistent, uneven, unpredictable. It isn't chaos in the sense of complete randomness. It is chaos of a subtler, more unsettling kind. There is structure, filaments, clusters, voids, but the rules you expect do not apply. Gravity, dark matter, and energy interact in ways that your mental picture cannot anticipate. The early universe is improvising its own arrangement, and every observation challenges your assumptions. Consider this. When you think of a galaxy forming, you imagine a slow accretion of gas, dust, and dark matter over hundreds of millions of years, guided by simple gravitational rules. Euclid shows that some galaxies already had massive cores much earlier than expected. Stars are forming faster than models allow. The early universe is neither slow nor polite. It moves in bursts, collapses in sudden shifts, and produces anomalies that defy linear explanation. Even the notion of cosmic density misleads you. You imagine a smooth gradient, a gentle rise and fall, but Euclid maps show a jagged terrain. Some regions are overdense, ripe for rapid galaxy formation. Others are underdense, vast voids stretching farther than intuition allows. The universe at this stage was not a canvas waiting for design. It was a storm of uneven growth, matter weaving itself into unexpected forms. Your instincts tell you that time should order this chaos, that eventually everything will average out. But the first billion years were not cooperative. These anomalies are not smoothed away by later evolution. They persist, leaving signatures visible even now. What you see in textbooks, the neat pictures of early galaxy formation, are simplifications, convenient narratives, not reality. Try to imagine yourself inside this early universe. There is no calm, no gentle unfolding. There is turbulence, tension, irregularity. Galaxies collide, merge, and explode. Streams of dark matter intersect unpredictably. Energy radiates unevenly, shaping structures that no linear rule could predict. The early cosmos was improvising, not following a blueprint. This is the first step in unlearning the universe you thought you knew. The order you assumed is only a veneer. Beneath it lies an unexpected, wild complexity that challenges every expectation. The Euclid telescope has made it impossible to pretend the early universe was simple, neat, or predictable. And if you thought you understood the passage of time in the cosmos, that too is about to be questioned. You think looking at distant galaxies is like looking back in time. You imagine a cosmic window, a literal snapshot of the past. Light travels from billions of years ago, reaching us now, and you assume that what you see is exactly what happened back then. That assumption feels solid. It isn't. Euclid has reminded us how fragile that intuition is. The light we observe is filtered, stretched, warped by space itself. Distance is not a ruler. Time is not a line. You picture a galaxy and think, this is what it looked like 12 billion years ago. But the reality is that what we see is a complex blend of signals, shaped by the expansion of the universe, by gravity along the path, by subtle interactions of matter and energy that distort the message. You imagine a universe where early light is straightforward, carrying simple information, but it isn't. Light is affected by the medium it passes through. Intervening matter bends it, stretches it, delays it. Photons scatter, redshift, shift energy. By the time the telescope collects them, you are interpreting a signal that has been filtered through layers of cosmic history you barely understand. What looks clear is deceptive. Consider how you judge the age of a galaxy. You measure brightness, color, distance, and then you infer mass and star formation. Simple enough in your mental picture, but Euclid reveals that these inferences are prone to error. Early galaxies appear brighter than expected. Some seem older than they should be. The models you trust are calibrated on assumptions that now seem unstable. Even your most careful measurements are tangled with the universe's own distortions. You may think this is a technical limitation, a minor inconvenience. But it's deeper than that. It forces you to confront the idea that even seeing is an act of interpretation. Distance is a construct. Time is a construct. Reality arrives at us already mediated, already processed by the fabric of space. The early universe you observe is a projection, a shadow, not the thing itself. Try to hold this. The universe is not simply there, waiting to be observed. It is constantly interacting with itself. And what you observe is always filtered through that interaction. The further back you look, the more tangled the signal becomes. That snapshot you trust, the one that reassures you about order, timing, and structure, is already misleading. Euclid's findings push this problem to extremes. Galaxies forming unexpectedly early, regions denser than models allow, anomalies that should be invisible at such distances. All of these challenge the very notion that looking far away equals looking back in time. Your intuitive sense of chronological progression, the line you draw in your mind from past to present, is unreliable. In this chapter, your belief in direct observation begins to crumble. You are starting to realize that even the act of seeing, even the act of measuring, cannot rescue your intuition. Distance and time are no longer trustworthy guides. What you perceive is filtered, warped, provisional, and often profoundly misleading. And if seeing the early universe cannot be trusted, then almost everything you think you know about it is up for reconsideration. You think matter follows rules. You imagine gravity, energy, and dark matter interacting in familiar ways. Galaxies form, stars ignite, clusters assemble, all according to the models you trust. That is your intuition. Euclid shows that this intuition is failing. The telescope reveals early structures that should not exist. Massive galaxies appear too soon. Stellar nurseries are more active than models predict. Cosmic filaments stretch farther, curve differently, twist unexpectedly. The universe is not misbehaving slightly. It is misbehaving fundamentally. You imagine physics as a rigid scaffold holding the cosmos in place, but in the early universe, the scaffold is bending. Gravity, dark energy, dark matter. They do not behave exactly as our models describe. Small assumptions you made about smooth expansion, uniform density, and linear growth are challenged. Euclid's observations highlight tensions between expectation and reality. Consider galaxy formation. You picture matter slowly gathering, collapsing under gravity, forming stars in an orderly sequence. Instead, Euclid finds galaxies that formed rapidly, with cores already in place, surrounded by sprawling halos of gas and stars. Some regions show accelerated structure, others lag far behind. There is no universal pace. The rules you assumed, linear, predictable, gradual, do not apply everywhere. Even cosmic expansion is more subtle than intuition allows. You imagine space stretching uniformly, carrying galaxies along like boats on a calm river. But the evidence suggests the river is turbulent, currents uneven. Dark energy, the driver of acceleration, interacts with matter in ways that remain poorly understood. This straightforward expansion you picture in your mind cannot account for the early complexity Euclid reveals. This is not a minor correction. It is a profound challenge. Every assumption about how the universe behaves at large scales is provisional. What you call laws of physics are models, approximations, interpretations, tools that now strain under the weight of new data. Try this thought experiment. Imagine you are inside one of these early galaxies. Gravity pulls, gas clouds collapse, stars explode. But the forces are not uniform. Some regions collapse faster. Some expand unexpectedly. Energy propagates unevenly. The structures form patterns that make sense only in hindsight, patterns that defy simple rules. The universe behaves like nothing you have ever encountered in your experience. Your mental crutch expecting cosmic order, smooth growth, predictable interactions is being removed. Euclid does not merely add detail, it undermines your assumptions entirely. It shows that the universe's early behavior is richer, stranger, and more abstract than your intuition can accommodate. You may ask, if the universe does not behave as we expect, how can we understand it at all? That is the discomfort Euclid introduces. The cosmos is not simply a bigger version of what you know. It is a system that follows its own rules, sometimes visible, sometimes hidden, always more complex than imagined. In this stage, your intuition is failing completely. The universe is no longer familiar. It is alien, uneven, improvisational, and you are only beginning to comprehend the scale of what that means. You imagine the universe as stable. You picture normalcy, galaxies forming in orderly sequences, matter obeying predictable patterns, the laws of physics marching steadily forward. That image feels safe. That image is wrong. Euclid shows that what we consider normal is a fragile illusion. Early structures, galaxies, clusters, cosmic filaments emerged under conditions far stranger than our textbooks suggest. Slight deviations in density, temperature, or energy flow led to massive differences in outcome. Small fluctuations in the infant universe were amplified in ways you cannot intuitively predict. Think of a thought experiment, a tiny perturbation, almost imperceptible, in a primordial gas cloud. You might expect it to smooth out, to be absorbed by surrounding matter, but in reality, it can trigger a cascade, a galaxy forming earlier than it should. Stars igniting prematurely, cosmic filaments bending into shapes no one anticipated. The universe is not self-correcting. Normalcy is an emergent property, fragile and provisional, dependent on an improbable balance of conditions. You imagine that today's cosmos, smooth, measured, seemingly ordered, is representative of the past. But Euclid shows that what you call normal is the exception, not the rule. The early universe was a patchwork of extremes, dense regions and voids, rapid star formation alongside barren stretches, galaxies assembling at impossible speeds. What you see now, the average structures, the familiar galaxies, are survivors, artifacts of a chaotic past. Even dark matter, the invisible framework we rely on to explain structure, does not behave as predictably as intuition allows. Streams intersect in unexpected ways. Clumps form where models predict none. Voids persist where none should exist. The apparent order we observe is merely the residue of countless improbable events. aligned just enough to produce the cosmos we recognize. Imagine standing on a distant world in that early universe. You see galaxies already shining, clusters already massive, and yet around you, the void is turbulent, chaotic, uneven. What seems normal today, the calm, predictable patterns would have been incomprehensible then. Normalcy is a construct, a lens through which we interpret survival, not a guarantee of the universe's behavior. Even the simplest assumptions about scale are misleading. You think there is a typical size for a galaxy, a standard rhythm for star formation, a common structure for clusters. Euclid demonstrates that in the early universe these scales were not fixed. The universe is experimental, improvisational, testing countless possibilities simultaneously. Normal, as you understand it, is not embedded in the cosmos. It emerges from survival, from patterns that endure long enough for us to see them. This fragility has consequences beyond mere observation. It reshapes how you understand probability, causality, and inevitability in the cosmos. The universe is not a clock ticking uniformly. It is a storm of possibilities, many of which collapse, others which flourish. Normalcy is only the narrow window through which we, billions of years later, perceive order. At this stage, your intuitive crutch, the idea that the cosmos behaves in a familiar, predictable way, is removed entirely. What you once called normal is provisional, contingent, and astonishingly fragile. The universe has no obligation to conform to your expectations. You imagine cosmology as a map of reality. Equations, simulations, and models are precise tools that reveal the universe's true form. That is comforting. That is wrong. Euclid's findings confront us with the fragility of every model we rely upon. The early universe does not behave according to neat approximations. Galaxies appear too early, dense regions too extreme, filaments too stretched. Our models are strained, contorted, failing to capture the full complexity of the cosmos. What you assumed was solid knowledge is provisional, temporary, subject to revision. You picture models as mirrors, reflecting reality exactly. But they are not mirrors. They are sketches. They are attempts to represent patterns we cannot fully see, guided by assumptions that now appear incomplete. Every dataset, every telescope observation is interpreted through these models. When the data shifts, so too must our understanding. The foundation of certainty, the equations we trust, quivers. Think of a mental experiment. Imagine building a structure based on incomplete blueprints. You fit the pieces together and it seems stable. Then someone hands you a new blueprint revealing that entire sections were misrepresented. The structure might stand, but the assumptions behind it are flawed. That is the position cosmologists now face. Euclid provides new blueprints showing that our earlier constructions, our models of the infant universe, were simplifications at best, illusions at worst. Even our most trusted constants, rates of expansion, distributions of matter, dark energy dynamics, must be reconsidered. Euclid's observations highlight tensions between theory and reality that cannot be ignored. Some models cannot accommodate the massive early galaxies it sees. Others underestimate the density contrasts across space. Every prediction is now provisional. What seemed universal is now conditional. This is not failure, it is revelation. Science is not about finding immutable truths. It is about testing assumptions, confronting anomalies, and revising understanding when reality refuses to conform. Euclid does not destroy cosmology. It forces it to confront its own fragility. your intuition, the sense that the universe is comprehensible in advance, is dismantled here. You can no longer rely on neat predictions. The models you hold are approximations, scaffolds, maps drawn on shifting terrain. They are guides, not guarantees. Even more unsettling, some of these tensions hint at unknown physics. There may be forces, interactions, or behaviors in the early universe that our current frameworks cannot capture. Our models are provisional not just because of imperfect data, but because reality may be stranger than we have imagined. By this point, you must accept a new mindset. The universe is not obligated to follow the rules we invent. Our equations, simulations, and assumptions are temporary lenses, always subject to correction. Knowledge is conditional. Understanding is iterative. And the cosmos, as Euclid shows, is always one step ahead of expectation. The comfort of certainty is gone. The universe refuses to be boxed in. Your intuition, your models, your mental scaffolding, all are provisional. Reality is stranger, more fluid, and more surprising than any human construction could predict. You think you understand the universe. You picture its history, its laws, its rhythms. You believe you can trace a line from the first atoms to galaxies to stars to life. That belief is comforting. That belief is wrong. Euclid shows that the cosmos is not a story written for comprehension. It is improvisational, uneven, and stranger than intuition allows. Galaxies appear where none should exist. Clusters form too quickly. Voids stretch farther than you imagined. What you see today is a patchwork of improbable outcomes, survivors of a wild, early experiment. Think of the universe not as a machine, but as a process that does not follow rules you can predict. Every observation, every photon captured by Euclid, is a message from a system improvising in ways we are only beginning to sense. The cosmos does not conform to expectation. It reveals itself grudgingly, in glimpses, through anomalies, through the strange. You imagine order, linear progression, inevitability, but the early universe was not orderly. It was turbulent, uneven, surprising, and this turbulence persists in the patterns we observe today. The structures you consider normal, the laws you take for granted, are emergent, contingent, fragile. They are not given, they are earned through billions of years of improbable events. Even the constants of physics, the scaffolding of your understanding, may only approximate reality. Euclid hints that there are behaviors in the early cosmos that strain every model. Forces, densities, and energy flows that we cannot yet capture in equations. You realize that your knowledge is a map of shadows, not the substance itself. Step back, let yourself feel the scale. The early universe was vast, violent, and improvisational. Every filament, every clump of matter, every star that ignited was part of a process you could not have foreseen. Your intuition, your mental models, your desire for simplicity, they all collapse against this evidence. And yet there is awe here, not comfort, not reassurance, but awe. Awe at the universe's capacity for surprise. Awe at its refusal to fit neatly into expectation. Awe at the strange, fragile beauty of emergent order born from chaos. The cosmos is more inventive than you imagined, more abstract, more unpredictable. It challenges your mind at every turn, forcing you to reconsider even what you mean by possible. This is the philosophical weight of Euclid's discovery. Reality does not owe you simplicity. It does not owe you familiarity. What exists is not designed for human intuition. And yet, in observing it, in confronting its strangeness, you glimpse something profound. A universe not constrained by expectation, a cosmos whose beauty is inseparable from its unpredictability. You close your eyes and realize the universe is not a story you understand. It is a story you inhabit, one full of improvisation, fragility, and wonder. And in that, there is something more terrifying and more magnificent than the neat narratives you once believed. The early universe is strange, the cosmos is fluid, and your intuition, your need for order, will never be enough. But in that absence of certainty, in that collapse of expectation, you find the awe that makes reality worth contemplating at all.